If you hold your hand near a glowing lamp or stand outside on a sunny afternoon, you can feel the warmth radiating against your skin. You aren't physically touching anything hot, yet thermal energy crosses the empty space between you and the source. We experience this constantly, but our biology has a blind spot. Human eyes only detect a tiny slice of the electromagnetic spectrum, visible light. Just past the long wavelength edge of that red light sits an entirely separate band of radiation, the infrared spectrum. Because we cannot see this frequency, it is incredibly easy to underestimate how much invisible thermal energy surges through our environment at any given second. There is a strict rule governing this part of the spectrum. Absolutely every hot object and its microscopic molecules generates and emits infrared waves. Because of this constant thermal generation, physicists usually refer to infrared radiation simply as heat waves. Look around you. An invisible sea of radiating heat fills the space between every object, existing alongside the light we detect with our eyes. To understand how these invisible heat waves actually warm things up, we have to look closely at their primary targets. In our atmosphere, infrared radiation interacts heavily with specific molecules like water, carbon dioxide, and ammonia. When an infrared wave strikes one of these molecules, it absorbs the energy. The molecule's internal vibration ramps up, increasing its thermal motion. This agitated molecule collides with its neighbors, transferring kinetic energy outward in a chain reaction that raises the surrounding temperature. That macroscopic feeling of an object getting hot against your skin is entirely the result of this microscopic transfer of kinetic energy. Scale that reaction up to the size of a planet. Earth operates as a massive thermal system locked in a constant exchange with the sun. Solar visible light easily penetrates our atmosphere, striking the Earth's surface where it is absorbed. The warmed ground re-radiates this energy as longer wavelength infrared radiation. Atmospheric water vapor and carbon dioxide absorb these outgoing waves, intercepting and scattering the heat back to the surface. The average temperature of the planet and the survival of our climate is dictated entirely by this precise, invisible physics interaction in the atmosphere. Once physicists mapped exactly how infrared behaves, engineers figured out how to artificially generate and control it. In medicine, physical therapists use specialized infrared lamps to safely penetrate skin and heat up deep muscle tissue, accelerating the body's healing process. In your living room, everyday remote controls rely on small semiconductor LEDs to pulse invisible infrared signals across the room to a television or stereo receiver. We have built an entire layer of modern comfort and healthcare around a frequency of light that our eyes are completely incapable of seeing. We have also scaled this engineering up to orbit, designing platforms that allow us to artificially see thermal signatures across the globe. Earth-orbiting satellites are equipped with highly sensitive infrared detectors. These instruments observe planetary phenomena that remain entirely hidden in the visible light spectrum. This data is used for high-stakes tracking, allowing analysts to monitor military movements through heat signatures or observe global crop growth patterns by analyzing the thermal health of vegetation. This invisible portion of the electromagnetic spectrum serves as a global infrastructure, dictating our climate stability, the precision of our healthcare, and the reach of our modern technology.